Okay, hi, everybody. Miss Lyons coming at you. So, what are we doing today? We have EF-3 exponent functions. Okay, so this little piece right here, you got a recall, right? Recall means that we've already done this in a few of our other lessons, and I'm going to leave this up to you. So I'm actually not going to give you the answers. I will tell you that there are 1, 2, 3, 4, 5, 6. There's 1 in this row. There are 3 in this row, and there are 2 in this row. Okay, so what you're looking for are which of these expressions are equal to x to the 8th. Okay, so there's 1 in this row, column, I guess you would say, 3 in this column, and 2 in this column that are equivalent to that. There's going to be a little recall in your homework, so if you have questions, make sure to ask us. Okay. Just to be reminded, we are moving on from exponents today, actually. So just to be reminded of your exponent rules, we have product. So that's when you have x to the a times x to the b. You can add those things together. So when you have a base that are the same with an exponent, okay, you can add your exponent. You have the quotient, so you would have x to the a over x to the b, okay? Well, then you can subtract those things. So it would be a to the x. I guess I'm writing kind of crooked. I'm writing crooked on my paper for some reason. So when you're dividing, you're subtracting. So dividing makes things smaller, so you subtract because subtracting makes things smaller. There's the power to a power. So if you had x squared all to the 4th or something like this, these two things you multiply together. So it would be 2 times 4, x to the 8th. Oh, there may be one of those like that in there. Anything to the 0 power is 1. And let's quickly look at one of these. I'm going to look at this one down here. So right in front of this little guy, this x, okay, this x has a -1 in front of it, okay? So this would be like -1x to the 8th, okay? It would look just like this. And when we have a power to a power, we put that exponent on everything. So I'd have -1 to the 8th, and then I would have x to the 8th. Okay, so in my calculator here, use parentheses because it's a negative. You should always use parentheses. And I'm going to put that to the 8th power. And this thing actually turns into a 1. Okay, and then x, well, there's a 1 here. Well, I have a power to a power. So this would be x to the 8th. So this is actually one of those that is equivalent to x to the 8th. Okay, that's old news now. Now to the new stuff, yeah. So what we're going to be talking today primarily is the difference between linear and exponential functions. So we talked about linear functions forever. Remember, we talked about lines, systems of lines, linear inequalities, all of those things we talked about already. Now what we're going to do is look at them in table form, and we're going to get some ideas what we're actually looking for, okay? So a linear function, okay? If we remember what a linear function looks like, it has the equation y equals mx plus b. Okay, so b is your y-intercept, right? So if I were to graph this, the first thing I would do is cover this slope. The b tells me where to begin. The m tells me how to move from that point. And notice in here, it says plus b, okay? So what's happening is this rate of change, if you're linear, this rate of change has to be constant. So it has to either be always going up or always going down. Can't change, okay? And all of these points, when we do rise over run, would be up 1, up 2, over 1, over 2, up 1, up 2, over 1, over 2. They always have to be the same. So what's happening is you are always adding the same amount to the point that you're at, okay? You're always adding an equal interval, a constant rate per unit interval, okay? So I'm going up 2 and over 2, rise over run, rise over run. This one, same thing, you would be going over 2, down 2, over 2, down 2, okay? So you're always subtracting the same thing. So when I have a table, what I want to do is always find the slope. So now what I have to decide is if I'm adding subtracting, multiplying, or dividing to get to the next number, okay? Well, I see here all of these numbers are getting bigger, so that means I'm either multiplying or adding, okay? So if I'm looking at 2 to get to 4, well, what are my options? I could either be adding 2 or multiplying by 2, okay? So this is plus 2, or it's being multiplied by 2, okay, to get to this number. Let's look at the next number, okay? So how do I get from 4 to 6? Add 2 or multiply by 2? Well, 4 plus 2 is 6, okay? 4 times 2 is 8. So this one is not multiplication. This one is an addition, okay? So plus 2 here, plus 2, okay, plus 2, okay, plus 2. Excellent. So I'm adding 2 on this side all the time. Okay, now let's look at this side. How do I get from 1 to 2, 2 to 3, 3 to 4, 4 to 5? Okay, I'm adding 1, I'm adding 1, I'm adding 1. Okay, so this right here, you notice how this over here and this over here does not change. You are adding a constant rate per unit interval. So you're adding 2 per 1 unit. You're adding 2 per 1 unit. You're adding 2 per 1 unit. Okay, so that's what we're going to write underneath here. So linear functions change at a constant rate per unit interval. Okay, let's put that in language that is more kind, I guess you would say. We're going to say AKA. What's happening is you are adding or subtracting to get to the next term, okay? Right? So what's happening? I'm adding the same amount on this side. I'm adding the same amount on this side. So I'm adding to get to the next number, right? And just to be reminded, y equals mx plus b, okay? Where you have your rate. This m has to be the same. Your slope, change in y over change in x, has to be constant for you to have a linear function. Now let's look at our exponential, or look at this table, okay? So let's look at how we're moving here. So 2 to 4. Okay, well, I can either add 2 or I can multiply by 2. Okay, now let's look at this second little section. How do I get from 4 to 8? Do I add 2 or do I multiply by 2? Okay, I'm multiplying by 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So I'm multiplying each and every time to get to the next number. Now what's happening over here? I'm still adding 1. Okay, so difference here is this has a common ratio of 2 to 1. Okay, so the exponential will change at a common ratio. Ratio basically means, A ratio is usually like a division or a multiplication over equal intervals. Okay, so for every 1 that I moved the x, I multiplied by 2. Every 1 I moved the x, I multiplied by 2. Every 1 I moved the x, I multiply by 2. In kinder words, AKA, to get to your next number, you're going to be multiplying or dividing for next number. And what does this equation look like? Well, the equation of an exponential function is y equals, and we're going to use what we normally see is a parenthesis times b, all raised to the x power. So notice how I'm adding in this one and I'm multiplying in this one, okay? So primarily that's what we're going to focus on today, looking at these things. Okay, so here is our exponential function equation. This is supposed to point to a. So let's make that a little bit more clear. So A, this is your y-intercept. Okay, this is your y-intercept in your function. Okay, so where x equals 0. We can also say that. So if you had a table where you had x comma y and it started 0, 1, 2, this right here, this number would go in for A. Okay, so it's the y value where x equals 0. B, well, this is what you multiply by. Okay, so I would start in my y-intercept, okay, and then the next number, like this, the first example, if I said times 2, times 2, times 2, times 2, I'm saying times 2, that means it's going to go right here in the B. This x, keep the x here. Okay, this is what we usually evaluate. So let's just jump into things that we see. This is my exponential function equation, and then my linear equation, y equals mx plus b. So what we're going to do is determine if this is exponential or is it linear, okay? Well, this first one says y equals 2x plus 4. Well, that sounds a lot like y equals mx plus b to me, yeah? Okay, so this bad boy is linear. Let's look here. I have y equals 2x plus, oh, nothing. So just 2x. But notice the exponent is a 1, okay? So the exponential, what you're looking for is for your exponent to be a letter, okay? So a dead giveaway for an exponential is the exponent is a letter. My exponent here is not a letter, so that would indicate linear. Okay, this one says y equals 4 times 5, all raised to the x power. Notice how my exponent is a letter. So this is exponential. Y equals a times b to the x. Exponential or linear. Okay, well, what is your exponent? Is it a number or is it a letter? Oh, it's a letter. So it's exponential. Okay. Alrighty, so consider this function, f of x equals 8 times 2 to the x. Answer the following. I want to evaluate each of the following and indicate what point lie on the graph of f of x based on each. Okay, so here's my function. F of x equals 8 times 2 raised to the x, and I want to know what happens when x is 2. So f of 2 is going to equal 8 times 2. And now this x, instead of seeing x, I'm going to write 2. Okay, so let's put this into our calculator. So I would have 8 parenthesis 2. If you want to raise something, you always hit this little caret button or the tent or TP, whatever. It's underneath your clear button. So power it up to the 2. And I get 32. Okay, what would this be as a point? Well, your input is your x, and your output is your y. So I would have the point 2, 32. What I put in and my answer. Okay, so let's look at this one. So I would have f of 0 equals 8 times 2 to the 0. Okay, well, anything to the 0 power, we remember, is 1. So this portion turns into a 1, and I just get 8 times 1, which is 8. Okay, we want to prove it to ourselves. There it is. Okay, what is this point? Well, my x value is 0, my y value is 8, and notice what I have here. I have y is 8, x is 0. I have the y-intercept. So where x is 0, this is my y-intercept. Okay, all right, last one. So f of negative 1 is 8 times 2 to the negative 1. So I guess what we can do here, if we didn't want to use our calculators, this has a negative exponent, so we could put it down to the bottom. And I now have 8 divided by 2, which is 4. Okay, but let's prove it to ourselves. So I have 8 times 2 to the negative 1, which is 4. And this would be the point negative 1 as my x, 4 for my y. Okay, so this is the point that must lay on the graph. Okay, calculate the average rate of change over f for the interval of negative 1, 0. Okay, so average rate of change. That is basically just asking you for the slope between the 2 points. What is the slope between negative 1 and 0? So the first thing I'm going to do is write down the 2 points. So I have negative 1 as my x value, and my y value was 4. I was given this. Okay. And then I have 0 for my x value, and my y value is 8. Okay. So now what am I going to do here? I'm going to do change in y over change in x. Okay. So this is x1, y1. This is x2, y2. And if I recall this, it's y2 minus y1 over x2 minus x1. Okay, so what am I calling x or y2? I'm calling y2 8. Minus is part of the equation. I'm calling y1 4. Okay, I'm calling x2 0. Minus is part of the equation. And I'm calling x1 negative 1. Okay, notice how I put that in parentheses. I didn't want that negative to get lost. So I put this into my calculator. I get 8 minus 4 is 4. And then I get 0 minus negative 1. Well, this double negative turns into a positive, so it's 0 plus 1, so it's just 1. But let's prove it. Perfect. 4 divided by 1, well, that's just 4. So my average rate of change is 4 between negative 1 and 0. Now let's calculate the average rate of change over the interval 0, 2. Okay, well, the first point I have is 0, 8, because that's when x is 0, y is 8. And then my second rate of change, x is 2, and y is 32. Okay. Again, how did I know that these were my x values? Is because it told me it was x right in front, right in the middle. So it told me you're looking at your x values. But rate of change, again, is change in y over change in x. Okay. So I'm going to take the difference in my y values. So I'm going to go bottom to top. So I have 32 minus 8 over, I'm going to go bottom to top again, 2 minus 0. Okay, so let's put that in our calculators here. I have 32 minus 8 on top, so I have 24. 2 minus 0 is 2. 24 divided by 2 is 12. Okay, so what does comparing the answers from B and C tell you about this function? Alrighty, well, 4 and 12. First thing I want to talk about. 4 does not equal 12. Since these two things are not the same, this is not a linear function because this is not moving at a constant number. You're not adding or subtracting the same amount to get to the next thing. So the rate of change is not constant. So let's see, f of x equals 8, 2 to the x is not a linear equation. Okay, we should have known this anyway because here's the equation, and yeah, we don't, holy moly. Not linear. Okay, sketch this function. So let's go to y equals, and I have y equals 8 times 2, all raised to the x. Okay, I'm going to hit this graph. Okay, it looks like this, but notice the scale here on this graph is way different than mine. So I'm just going to hit window. My x's, this is my x, goes from negative 4 to 4. And my y goes from negative 10, y min is the minimum y value, the smallest. And then the biggest is 130. So I'm going to make my table, my little graph look just like this one. Okay, so it comes in along this line just like this, and then it's going to shoot up really fast. Okay, so this is what exponentials look like. They're kind of like a smiley face, I guess you could say, or it could be like a sad face. Okay, excellent. Alrighty. These ones should go pretty quick. All we're doing is throwing things into our calculator here, okay? So f of x when 4 times 5 raised to the x when x is 3. So all we're doing is 4 times 5 when I raise it to the third power. 4 times 5 raised to the third power. Oh, that's a big number. Okay. Next one. 1,000 times 1.06 when x is 0. So I'm plugging in 0. Anything to the 0 power is 1. Therefore, I'm left with 1,000 times 1, which is just 1,000. Okay. Next one, when x is 3. So I'm going to have 2/3 raised to the 3rd power. Okay. Put this in a fraction. Notice I hit alpha x. Uh-oh, I better put it in parentheses. This is in parentheses, so mine better be in parentheses. To the 3rd. Okay, that's 8/27. Okay. Because, never mind. I'm not going to go into that with you right now. And then lastly, when x is 4, I get 80, parenthesis, 1/2 raised to the 4th power. So I get 5. Okay. Next question says, which is exponential, which is linear? I hope that you can tell me now which one of these is linear and which one is exponential. This top one is linear. Okay. This has a constant rate of change. Okay, what does that mean? It means that for every one it goes up, it goes over the same amount every single time. Doesn't change. So the distance between all of these dots is equal. Okay, this one is our exponential. Okay, and what happens here? Well, the reason it's exponential is because the distance between these dots increase more every time. So this little line segment is a little smaller than this one, which is a little smaller than this one, which is smaller than this one, which is smaller than this one. Okay, so exponential increases get greater over intervals. Okay, constant rate of change doesn't change, increases a lot. Okay, all right, and then we are on to our last example. This one is the toughest one. Does the table represent a linear or exponential function? How do I know? Okay, so what I'm going to do here is decide on how these numbers are moving. Left-hand side, I'm adding 1, adding 1, adding 1. Okay, good. This side. Okay, so I'm starting at -7, and then I'm getting to -5, and then I'm going to -3, and then I'm going to -1. So how many units are between these two numbers? Not the negative signs, just units. So 5 to 7, okay, well that's 2 units, right? So if I were sitting at 5, or if I were sitting at 7 and I want to get to 5, I would be moving 2 units. So let's look at a number line. So here's -7, -6, here's -5, -4, here's -3, -2, here's -1. Okay, so if I were starting right here and I needed to get here, what would I be doing? 1, 2. I'm adding 2 because here is 0. I'm getting bigger by 2. So this is +2. What about -5 to -3? Well, 1, 2. I'm adding 2. Okay, how about -3 to -1? 1, 2. I'm adding 2. So notice how I'm adding the same amount the entire time. So I have a constant rate of change. So this one is linear because you have a constant rate of change. Okay, let's look at this one. I have -2 to 0, 0 to 2, 2 to 4. So what's happening here? I'm adding 2 every single time. Okay, now what's happening over here? So if I'm at -5 and -4, -3, -2, -1, 0, 1. Okay. How am I getting from -5 to 1 and then 1 to 7? Let's talk about adding first, okay? So how many do I have to add here? So 1, 2, 3, 4, 5, 6. I have to add 6 to get from -5 to 1 because it's getting bigger. I have to add 6 to get from 1 to 7. So that's right. So I'm adding 6, adding 6. Do I have to add 6 to get to 13? Yep. Okay, so notice how I'm adding the same amount over the same interval. So I'm adding a constant change. Okay, so this is linear. All right, let's look at this last one. So if I were at 3, 4, 5, 6, 7, 8, 9, and I want to get to 9, what would I need to add? So 3, 4, 5, 6, 7, 8, 9. How many is that? 1, 2, 3, 4, 5, 6. So I'd have to add 6. Okay, so if I add 6 here, I get to 9. What is 9 plus 6? Okay, so 6 plus, oopsies. So 3 plus 6 is 9 plus 6, 15. Is this 15? No. Okay, so this one is not adding. So since this one is not adding, this one is not linear, okay? So how would I get here? Well, how do I get from 3 to 9 if I were multiplying? Because it's getting bigger, so I have to multiply. So 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. How's this side moving? Plus 1, plus 1, plus 1. Common ratio. Ratio means multiply. So this is exponential. Okay. Alrighty, my folks, my lovely little beings. We are all done. I hope you have a wonderful day.